Hello everybody, welcome to Introduction to an Ordinary Differential Equation. Today I am going to teach about differential equations, definition of differential equations, types of differential equations, order and the degree of differential equations, and some examples on order and the degree of differential equations, linear and the nonlinear ordinary differential equations, and the method of solving ordinary differential equations. If you are ready, let us begin. As introduction, what is differential equation? A differential equation is equation that involve dependent variables and their derivatives with respect to the independent variables. That means in a case of, for example, dy divided by dx, in this case y is dependent on variable x, which is an independent variable. Therefore, a term which describes such like relationship or a relationship between dependent variable and independent variable is known as differential equation. There are two main types of differential equations: ordinary differential equation, partial differential equations. Let us see one by one. An ordinary differential equations are equations that contain derivatives with respect to only one independent variable, so there may be multiple dependent variables are there. That means for only one independent variable we maybe have multiple dependent variables. For example, in first order ordinary differential equations, we may be write in the form of dy divided by dx plus y is equal to x. In this case, y is first order and we have only one independent variable and one dependent variable. But in a case of second order ordinary differential equations, we may have two dependent variable for only one independent variable. Example, in the first case, dy divided by dx, which represent an ordinary differential equation, y is dependent on x. And also in the second case, the degree and the order of the differential equation may be different. We will learn about order and the degree of ordinary differential equations in the next slide. For now, we are looking only for dependent variable and independent variable. In this case, n represents number of derivatives. What is a partial differential equation? A partial differential equation contains a partial derivative with respect to multiple independent variables. A partial differential equation contains partial derivatives with respect to multiple independent variables. In this case, we have two variables are there or more than two variables are there. In a partial differential equations, one variable or dependent variable is differentiated with respect to more than 2 times with an independent variable. A partial differential equation is used to describe or used to find area of a sphere, volume of spheres, or volume of cylinders. A partial differential equation also describes polar coordinates, cylindrical coordinates. Example: to describe electric field, we use a partial differential equation. In a case of a partial differential equation, dependent variable is summation of more than two functions or two variables. For example, when we find a volume of spheres, we maybe differentiate partially 3 times variables, such are z-coordinate variables, x-coordinate variables, and y-coordinate variables, vertical variables or horizontal variables, or width variables, depth variables. Order and the degree of ordinary differential equations. The order of a differential equation is the order of the highest derivative found in the differential equations. Orderii differential equationii jechuun orderii deriveetivii baay'ee ofirraa qabu jechuudha. Fakkeenyaaf first order kan jennu y'n yeroo tokko qofa x wajjin yookiin variable biraa wajjiniin jijjiiramaa biraa wajjiniin differentiate kan ta'u yoo ta'e first order yookiin orderii tokkoffaa jenna. Y'n yeroo lama differentiate ta'a yoo ta'e yookiin immoo yeroo lama derivative ta'a kan ta'u yoo ta'e orderii lammaffaa jenna jechuudha. Akkasumatti itti fufee yeroo sadii kan ta'u yoggaa ta'e variablein kun si'a meeqa differentiate ta'e si'a sadii differentiate ta'e waan ta'eef orderii sadaffaa jenna jechuudha. The order of derivatives is the number of times the dependent variable is being differentiated with respect to the independent variable. We may be right in many functions or functions which have many times differentiated in the form of y the power of n's when n represents the order of the ordinary differential equations. Example: dy divided by dx, which is y first, comma, which represents first order ordinary differential equation. In example 2, y is differentiated 2 times with respect to x. Therefore, the order of this differential equation is second order or 2. In the third case, y is differentiated 3 times with respect to x. So the order of this differential equation is going to be 3. We also high order ordinary differential equations write in the form of y the power of n's, which n represents the order of ordinary differential equations. We are given some examples here. Let us see this example. What is the order of each of the following differential equations? Let us check all terms one by one. On the first term, u is differentiated 2 times with respect to x plus. Second term, u is differentiated 2 times with x, and the 3 is exponent. In the third term, u is not differentiated, only we have normal u. Therefore, the order of this ordinary differential equation is the highest term is on the first term, which is 2. In example B, the first one, u is only differentiated one times with respect to x. On the second term, u is not differentiated with respect to x, and the third term, which is ln x, is a normal function. Therefore, the order of this differential equation is du divided by dx, which is 1. On example C, let us check one by one. On the first one, y is only differentiated 3 times with respect to x. On the second case, y is differentiated 2 times. On the third case, y is differentiated 2 times with respect to x. Therefore, compare the highest order which is exists on those terms. For the first term 3, for the second term 2, and for the third term, which is 1. Comparing 3 to 1, 3 is the highest term. Therefore, the order of these differential equations is going to be 3. Let us check the answer on the next slide. Solution. Example A, order is 2. Example B, order is 1. Yes, right. Example C, order is 3. Therefore, we are correct. Degree of ordinary differential equation. A degree of ordinary differential equation is the highest power or exponent of the term with the highest order, but it should be positive integer. Understand it. To define or to find the degree of ordinary differential equations, the exponent or the power of the term should have two positive integers, not a decimal, not a fraction. But if we are facing with a problem which their exponents are decimal or fraction, we should have to change into positive integer. If it is a decimal or if it is a fraction, we should have to squaring or cubing, or we should have to multiplying by a factor of that fraction and change into that fraction into positive integer. Unless otherwise, we cannot define degree of that ordinary differential equation. Now let us see some example about both order and the degree of ordinary differential equation. Example A, check for both order and degree of ordinary differential equation. Compare all terms which have the highest order and the highest degree. But on the degree, you should have to find carefully or describe the degree of ordinary differential equation, because degree of ordinary differential equation is dependent on order of ordinary differential equations. To define degree of ordinary differential equation, first of all, you should have to identify the order of that ordinary differential equation. For example, in example A, first term y is differentiated 3 times with respect to x, and then in the second term y is differentiated 2 times with respect to x, and in the third term y is not differentiated, which is normal y. Therefore, compare first term and second term which have high order. The first term 3, the second term has second. Therefore, order of this ordinary differential equation should have 2, 3. Now to find degree of this ordinary differential equation is very simple, because we said that the degree of ordinary differential equation is dependent on order of ordinary differential equation. Therefore, what is the exponent of the first term, which is 5? Example B, on the first term, y is only differentiated one times with respect to x, and the second term y is 3 times differentiated with respect to x, and in the third term y is differentiated 4 times with respect to x. And check for a decimal or fraction and a negative exponent. All are written in the form of positive integer. Therefore, now compare order of all terms. On the first term, we have only one order. On the second term, we have 3 order. On the third term, we have 4 order. Therefore, the order of this ordinary differential equation should have to exist on the fourth order or the fourth term. Therefore, the order of this ordinary differential equation is 4 and its degree is 1. In example C, first check the left-hand side. The left-hand side is written in the form of positive integer, which is first or third order ordinary differential equation. Now let us check for the right-hand side. The right-hand side, which is a term which is in the bracket, its exponent is written in the form of 3 over 4, which is in a fraction form. Therefore, it violates the rules and the principle to find the degree of ordinary differential equation. Now we should have to change this fraction number into positive integer. To change this fraction number into positive integer, we should have to multiply this number into some factor which changes this fraction into positive integer. Now let us multiply the whole function by 4. The right hand side is going to be y third order, which exponent is 4 plus 2x to the power of 4, which is equal to y second order minus 5 to the power of 12 over 4, which is going to be 4. Therefore, the order of this differential equation is multiplying by 4. We got what? In this case, this 3, which is not 3. Yes, the order is 3. Is y is differentiated 3 times with respect to x. What is its degree? Its degree is 4. Now, let us take some notice about ordinary differential equations or degree of ordinary differential equations. Some ordinary differential equation may not have degree because when ordinary differential equations or variable y or dependent variable is a product of some function, that function may have order but may have not a degree. To define or to identify degree of ordinary differential equation, the degree of differential equation is identified only after the exponents of all the terms with any order derivatives are made to have positive integer exponents. Termoonni orderii kamiiyyuu positive integeritti erga jijjiiramanii booddee digirii differentialii equationii sanaa barbaaduu dandeenya jechuudha. Lammaffaan immoo degree of differential equation is defined only if the differential equation is a polynomial in all the terms with the derivatives looks like. Differential equationichi degree isaa ibsamuu kan danda'u differential equation kun termoota kamiiniyyuu polynomial equation first order, second order, third order fi nth order haala kanaan barraa'uu kan danda'u yoo ta'e qofaadha. If the following functions are product of any order, the ordinary differential equation has not a degree or its degree is undefined. Example, sin y first order by second order function. We are given with some problems to find the order and the degree of ordinary differential equations. We will solve these problems on the next lecture video, problem solving on ordinary differential equations. Now let us define linear and nonlinear ordinary differential equations. What is the difference between linear and nonlinear differential equations? As a definition, a differential equation is said to be linear if and only if the following two conditions are fulfilled. The first condition, the dependent variable and its derivatives in all terms of first degree. Variably hirkataa fi yookiin jijjiiramaa hirkataa fi derivatiiviin isaa termoota kamirrattuyyuu first degree yoo ta'anidha kan inni jedhu. Maal laalla asirratti orderii tokko yookiin ammoo digirii tokko define gochuudhaaf orderii jalqaba laalla jennee akkuma turre differential equation tokko ammoo linearidha jechuudhaaf jalqaba irratti maal check gochuu qabna. Variably dependent yookiin immoo variably differentiate ta'e kuni digriin isaa maal akka ta'e identify gochuu qabna jechuudha. Digriin isaa tokko yookiin immoo first ta'uu qaba jedha. In a B, there is no term involving product of the dependent variable and any order of its derivatives. Kun immoo kan inni jedhu dependent variable kuni baay'ata functionii kamiyyuu ta'uu hin qabudha. Erga functionichi kuni baay'ata kamirraayyuu bilisa ta'e yookiin ammoo erga salphisneen booddetti free from any function erga ta'een booddetti linearii fi non linearii ta'uusaa adda baasuu dandeenya. Kanaaf linearii ta'uudhaa fi productii functionii kamuu ta'uu hin qabu kan inni jedhu. Any differential equation that contains the following equations are non-linear. For example, sin first order product of cos first order y, sec first order, ln first order y, and any order which are not linear differential equation or such functions are automatically non-linear functions. Example, identify the following equations linear or non-linear. To define or to identify linear and non-linear differential equations, we have already seen two rules on the previous slide. The first one, y for second order minus 6x dy divided by dx is equal to sin 3x. We may write this equation in the form of y minus 6x y first order, which is equal to sin x. In this case, in the first case, which is fulfilled the condition, but in the third case, y which is a product of x. Is this linear or non-linear ordinary differential equation? This is non-linear ordinary differential equations because the second term is a product of dy divided by dx. What is example B? Check for the rules above. Y first second order minus 5y first order minus y 2 over 3, which is equal to sine x. This is linear ordinary differential equation. What about this third example? On the third terms we have sine y. Is this linear or non-linear? This is linear ordinary differential equation because sine y is not differential, it is y normal. What is example D? In example D, on the second term, y is a product of cosine function. Therefore, this is automatically non-linear differential equation. What is example E? On example E, y is differentiated with respect to L, which is first or second order, the first degree. Therefore, it is linear ordinary differential equations. Now let us see about solving first order differential equations. Any differential equations of the form m of x comma y dx plus n of x comma dy or dy divided by dx is said to be first order differential equations. Method to solve first order ordinary differential equations. There are many ways or many methods to solve ordinary differential equations. Among them, some are here. First method, separable differential equations or method of separation. Second order, homogeneous differential equations or change of variable. Exact differential equations or method of exactness. Non-exact differential equations or integrating method factor. And the final one is Bernoulli's differential equations. Separable ordinary differential equations. A first order differential equation is said to be separable if after solving it for the derivatives dy divided by dx equal to f of x comma y. The right hand side can then be factorized as a formula of just x times a formula of just y. F of x equal to f of x times g of y. In this factoring is not possible. If this factoring is not possible, the equation is not separable. dy divided by dx is equal to f of x times g of y. We can solely differentiate and integrate such like function, and the function is known as separable ordinary differential equation. Example, consider the differential equations which is written in this form. Solving for the derivatives by adding x squared times y squared to both sides, we come up with such like function and then factorizing out the x square on the right hand side, it gives this like function. Then we can simplify in dy divided by dx form. Then f of is equal to x square, no y's exist on these terms, and the dy is equal to 1 plus y square, no x is found. On the other hand, consider dy divided by dx. Solving for the derivative here, the hand right side of this clearly cannot be factorized into a function of just x times a function of just y. So this is non-linear. This is non-separable ordinary differential equations. On the next lecture, we will solve some problems on separable ordinary differential equations. Thanks. Don't forget subscribe, share, and like.